Hi guys, it's Daniel here, and today I'll be doing 2015 USAJMO problem number 1. Let's start by reading the question. Given a sequence of real numbers, a move consists of choosing two terms and replacing each with their arithmetic mean. Show that there exists a sequence of 2015 distinct real numbers such that after one initial move is applied to the sequence, no matter what move, there is always a way to continue with a finite sequence of moves so as to obtain, in the end, a constant sequence. So in this solution, I'll be going through a little bit of my motivation along with the actual solution. So you get an idea of how to actually solve the problem, and it doesn't look like totally like magic or something like that. So let's begin by first analyzing what happens with, for example, three numbers. So if we have A1, A2, and A3, actually let's do five numbers, A4, A5. Then first we can, I guess, take the average of any two of them, and we get some other number. I don't really care. Two x's. And we can just keep on taking averages like this and like this. But notice that when we have to end up with all of them equal to the average. So when the first move that gives us two numbers that become the average. Well, since those two numbers become the same number, and they both become the average, then that means those two numbers both turn into the average. And then we can continue with this logic to get that these numbers turn into this average in pairs. So if we do this pair, then this pair, but then we have this low number here. This tells us that this low number was the average to begin with. But since that if we had none of these being the averages, then the first time that one of the numbers turns into the average, we have two numbers turn into average. This tells us that this one number was the average from the very beginning. Okay, so this tells us some stuff, that out of all the 2015 distinct real numbers, A1, A2, all the way to A 2015, one of the numbers begins as the average. So let's just call it this. Let's call the average, like, I don't know, x or something like that. So this is equal to the average from the beginning. Now comes the bit of like intuition, because we have a bunch of other numbers that we don't know, and we just need to find one such sequence such that this condition is satisfied, that all of them turn into a constant sequence. So what if we have A2 and A3, if they average together and to equal x, and A4, A5, they average together equal x, all the way to the end. Maybe this sequence works. So I'll go construct this sequence. Excuse me. Let's go down, construct the sequence. Let's let x be the average, and the next number can be x plus k1 and x minus k1. We see that if we average these two, they become x, and then x plus k2 and x minus k2, they average together all the way to x plus k1007 and x minus k1007. These two average together to equal x. So maybe this sequence works, and I will prove that it does work. So we have a few cases first. The first case is the first pair that we choose, the random pair that we choose, that we average together. This is of the form x, case 1. This is the form x plus or minus ki and x plus or minus kj. And these, actually, never mind. Let's just consider this first. If we have these two averaged together at first, this turns into x plus or minus k1 ki plus kj over 2. So we have two cases of this. 2 times of this. Now we have like our own choice of what to move. So let's choose x minus or plus ki and x minus or plus kj. And this minus or plus just means it's the opposite sign of the plus or minus. And this averages as x minus or plus ki plus kj over 2. And this, we have this number 2 times. But if we just average these two pairs, then we get 4x's times 4, which x is the average of all the numbers, so that's good. Now let's consider all the other numbers in here. Well, they're just of the form x plus or minus km and x minus or plus km. Well, actually, I can just write x plus km and x minus km, same thing, and x minus km, where 1 is less than or equal to m, which is not equal to I and j, less than or equal to 1007. If we take these two numbers and average them, we get 2x's. But then that means all the numbers become x's. So that means we're done for this case. Now let's go to case 2. Oops. Not enough space here. Drag it down a little bit. There we go. Case 2 is where we have x plus or minus ki and x minus or plus kj. And this solution is practically identical to the previous case, so I'm just going to save some time and not do it. So let's make this board a little bit wider. There we go. So there's one more case that we need to take. It's that case 3, that starting averages is the number x and x plus or minus ki. Now for this, we can't like pair up x minus plus ki with something, because there isn't another x. There's only one x, so we can't do that. But maybe we can create one. So after this move, which creates x plus or minus ki over 2, let's take x plus or minus kj and x minus or plus kj and average them together to get 2x's. Now we can take one of these x's and average it with x minus or plus ki to get x minus or plus ki over 2. And this happens 2 times. But then we can just take this and average it with this to get x. And this is 4 times. But now we have a bunch of x's. And x is the average, so this is good. And finally, we can just finish it off with x plus km, x minus km, average these together, where 1 is less than or equal to m, which is not equal to I and j, and less than or equal to 1007. We average these, we get 2 x's per pair, and now all the numbers are x's, they're constant, so we are done.
Hey guys, Zonker, back with another math video. Today we're going to be doing USAJMO, but I thought it's